are going to talk about the differences of factoring versus solving, and just kind of basically give you guys a couple of quick examples of the different styles of factoring. So the first one we're going to do is something very basic. The leading term coefficient here is what?
1.
1. That's the stuff that makes you happy. Okay? That's the stuff that makes you happy. Now, the way I grew up factoring, the way that I've always done it, was a little T-chart stuff. Okay? I've always done it this way. I know that there are tons of different methods out there. If you guys had 7, you probably did the box method stuff. Maybe for the 3 problems in geometry that you had to factor. Depending on who you had for algebra, you did things a bunch of different ways. This was kind of like the tried and true way of always doing it, and I always thought it worked. So what I'm always asking myself here is, we're going to take this trinomial and write it into 2 binomials, the multiplication of 2 binomials. We're unfoiling, remember that?
Yes.
So what we're going to ask ourselves is, what times what is negative 28, but you add it together, you get negative 12. What are the factors of 28? When you add them together, you get 12. Yes, ma'am?
Is this going to be part of the non-calculator portion?
Of course. There'll be non-calculator, calculator, this stuff as well. Yes, sir?
Negative 14 times 2.
Perfect. It's negative 14 and a 2. When you add those together, you get negative 12. Now, I'm showing what it looks like in that little chart thing. You don't have to. I know a lot of you guys can probably say, oh, it's negative 14 and 2. When you go to put that into the terms, the stuff that's in the parentheses, does it matter which one goes first? Nope. Actually, it doesn't matter at all. It doesn't matter at all which one you put first. It makes absolutely no difference at all. Because what's 2 times 3?
6.
What's 3 times 2?
6.
For 1 million points, what property of math is that?
Addition.
Wrong.
Wait, what?
It's the,
It's when it's
Commutative property, yeah. Ben gets 1 million points.
I did.
Oh, right, that's a lot of points.
Okay? What is the difference between seeing something where it says this or that? What's the difference? You have to solve.
yeah.
The only difference here is when you see the equal sign, you take it that one last step further, and you're asking what are the zeros. And we kind of done something like that before. So if I wanted to find what are the zeros of this, what are the zeros of this?
14.
And?
Negative.
Okay. 14 and negative 2 would be considered your zeros of the function. Okay?
It smells like the frogs that we dissected. I think it might be your marker. Burning plastic. You're telling me the sniff markers?
They're not toxic.
It might not. It's not good.
Oh.
It smells like fancy.
All right. Okay. What times what's negative 21? You add together to get positive 4. 7 and 3. Which one's positive? Which one's negative?
Negative 7.
Okay. Do we vaguely remember this?
Yeah.
Yeah.
Do you know how to check?
You go back and boil it.
You foil it. You guys don't know this guy. You know this. Billy Binomial? You don't know Billy Binomial?
No.
Let's introduce you to Billy Binomial.
Please don't.
When you guys foil, you use what's the F stand for?
First.
First.
Outside. Inside. Last. Fun.
Why?
It's Billy Binomial.
Wait, I know. Wait.
Squint.
On his equal letter, oh my god.
It's Billy Binomial. His nose. He's got like big nose. Oh no, what times what is positive 28? You add together to get negative 11.
4 and negative 4 and negative 7.
Good, remember your signs. One of the things that people tend to forget are some of the rules with the signs. Remember when you have a positive and a negative, and the last one's positive, the second term is negative, the last one is positive, that means both terms are going to be negative. Okay? But there's a difference between a term and a zero. Your term is what's in the parentheses. The zero is when you set it equal to 0. Okay? We use a lot of that in algebra here. I'm talking about different terms and zeros, especially when we get into polynomials, because we'll be using and writing out terms and zeros and polynomial functions via division. Awesome. It's easy though.
2 and 4.
Oh no,
Two different problems.
there are two different problems, and I'm afraid of them.
2.
There's equal signs, correct?
Yes.
That means you have to do what when you're done?
Solve.
No, we're not graphing. Don't worry about graphing it. We'll get there. It's exciting. All right. So when I go to start out the first one, I have x squared plus 6x plus 8, which means what are your two terms?
4 and 2.
And then what are your zeros?
Negative
Negative 2.
What happens here, sometimes they won't put it equal to 0. They might just throw a y equals. Okay. Whenever you see an equal sign, that means you just take that one step further to get the zeros. Okay. That's always the rule. The second part here. What do you do first now?
Multiply the first one and the last one.
First rule of factoring is always to ask yourself, what is that called? No. It starts with a G and ends in a S.
Greatest
There's a C in the middle.
common factor.
Very good. One of the things that people tend to forget about, you're right, you can multiply first and last term together and do all that stuff. But a lot of times whenever you have factoring problems, you always want to look for a GCF if you can. In this case, if you do a GCF, what do they have all in common? 2. So you factor out a 2 and you're left with x squared minus x minus 12. It's just easier to factor. Okay? Now, when I go to factor that, I have to figure out the two things multiply from negative 12. They add together to get negative 1. They are?
4 and 3.
Which one's positive? Which one's negative? Negative 4. Good. Now remember, this is equal to 0 here. What happens to that 2 out front?
You have to.
Oh, that's a good thing here. I'm glad you made that mistake. Do you guys subtract the 2 or divide the 5 by 2? So on the test the other day, when there was a problem that looked like, I don't know, 5100 equals 20 negative, I don't know, something along those lines, and you guys just kind of went, oh, I'm going to add 20. And you got that question wrong. Because how do you undo multiplication, ladies and gentlemen?
You divide.
Divide. I was astounded the number of people that did that. Don't do that. Yeah, if you divide out by the 2, it just kind of goes away. What will happen more often than not, whenever you factor out a GCF, it has no bearing upon the zeros. It has no bearing upon it whatsoever. Okay? Because since that side is already equal to 0, if I divide 0 by 2, I still have 0. Okay? So sometimes I might get lazy when we factor out GCFs. I might just stop writing them down. It's really have no bearing upon the problem. Okay? You have zeros in this case of 4 and negative 3. Not so bad? All right. Let's do the tough stuff then.
Okay, why would they like write our calculator square? Is there a reason for that, or we just?
When I just cut it from the book, that's all.
Oh.
That's all. There's no reason. We could do systems of quadratics if you want.
That's
Well,
what I
I mean,
thought.
We will be.
Oh, okay.
It's easy.
Not
It's
right
very,
now,
very
though.
easy. It's easy to do.
I was saying that like sarcastically.
No, it's very simple to do.
I think that's Monday for holidays. We should just bring them back.
Yeah.
I heard something
about
Monday.
Monday.
Joe, I thought you were discussing
All right.
Yeah, good luck.
This is where things start to get interesting. Special patterns. Special patterns. There's no middle term here, is there?
No. I remember.
It's a what?
Like the common difference, maybe?
Kind-ish. Perfect square.
Yeah.
Now, here's one of the tricks here. This is some of the things you probably have forgotten. When you start to look at these things that have two terms, there's a couple quick questions you ask yourself. Is the first term a perfect square?
Yes.
Do you remember what that means?
Yes.
No.
Like, isn't it very square and it's like perfect?
That's awesome. Perfect squares are two numbers that are the same that multiply to get the other. So 5 times 5, 4 times 4, 3 times 3, things like that. So your perfect squares are going to be 1, 4, 9, 16, 25, 36, 49, so on and so on. So is this first term, x squared, is that a perfect square? Is 1 a perfect square? Is that a subtraction symbol? If you can say yes to all three of those, then your two terms are the ones that alternate the signs.
Alright.
It has to be a subtraction sign. If it is not, it won't work.
What are the rules to follow?
The rules to follow again. First term, is it a perfect square?
Okay.
Last term, is it a perfect square? Is it a subtraction symbol? If it is, then you can do that. Okay? Now remember, what's happening here when if you FOIL all that out, you get x squared minus x plus x minus 1. Your middle terms drop out. Okay? That's what that looks like. It does not work with addition. Never. Never, never.
So that was
Yes,
plus
ma'am. I'm sorry, that's the perfect square. This is the difference of squares. Did I say perfect square?
Yeah.
Okay, sorry, this is the difference of squares. The perfect square is the other one. I'm sorry, I misspoke there. This is called the difference of squares. This is, you don't need to know what it's called. I'm not saying which property is it? Well, it's technically, it is the difference of squares. The perfect square is the one that has the same thing twice. I misspoke on that one. I was thinking of it the other way. Remember, it's the first. No, but I'll show you that one. You'll pick up on it real fast. The difference of squares rules with what we were saying, yes.
Okay.
I just called it the wrong name, that's all. What we're talking about here is the other one, where it looks like this. X squared plus 10x. Now, a lot of times with this one, this itself is the perfect square trinomial. I normally don't even bother with those special patterns for this one, because I can still do the same thing. What times what's 25 add together to get 10? 5 and 5. So a lot of times if you want to go with the special patterns on this, the way that the book, or the way that everybody's always explained the perfect square trinomial is the first term perfect square, it's the last term perfect square, and is the middle term the sum of the perfect the sum of the square roots of the last term.
Yeah.
That's a lot of work for what times what's 25 to add together to get 10. See what I'm saying? It's one of those things, okay? It's one of those things. Now, another thing that they will do with this, instead of writing it as x plus 5 times x plus 5, they write it as x plus 5 quantity squared.
Oh.
Junk times junk is junk squared.
That's it.
You ever heard that before? Junk times junk?
Yeah.
We use that a lot. Your book talks about the perfect squares as far as with addition or with subtraction. Like I said, it's one of those things that I normally don't spend a lot of time on because I like the quick patterns. I think it's easier to remember. There's no need to remember all the special rules for it. That's just my own thing. Is this a difference of squares?
Yeah.
Is the first term a perfect square?
Yeah.
Is the last term a perfect square?
Yeah.
Is that a subtraction sign?
Yeah.
So what are your two terms?
X plus 7 doesn't matter.
Okay. Once again, does it matter which one goes first?
No.
Yes.
Not at all. Doesn't matter whatsoever. Okay? Yes, sir.
Wait, if it wasn't like that, would you just put like cannot be determined?
Yes, sir. Yeah. If it was x squared, plus 49, you can't do that. Okay? You just say no.
No solution.
No. Say no. There is a solution, but we're not going to do that yet.
Alright, so cannot be determined or be.
Cannot be determined is fine. What's wrong? You're looking at me like you're ready to be really bad because I said there will be a solution for that at one point. Yes.
Oh,
I did these. All right. Let's make it. Now the nasty stuff. When you have a leading term coefficient that's not equal to 1. Once again, I know that there are many, many, many different ways to factor. I'm a traditionalist. I really like the old way of doing it where I use what's called factor by grouping. You guys remember that?
Yeah.
I use that method because it will always work. It might take an extra step to do it that way, but it forces you to do it correctly. Yes, ma'am? No, to be honest with you, I've never, Seth is trying to show me the box method of doing this so many different times. Mr. Chains has tried to show me that. I have no idea. I've tried it, I just can't make it work.
That's pretty easy.
If you want to do it that way, that's fine. If you want, because here's what I do. I do the same thing I was doing a minute ago. What's 3 times 10?
30.
Okay. What times what is 30? You add together to get negative 17.
Negative 15.
Perfect. Everybody see that? It's negative 15 and negative 2?
Yeah.
Why did you do 30?
3 times 10.
Well, like why?
This is the method that is, I'm going to do what's called factoring by grouping. I take that first term and I multiply it to the last term. Because if you go back to just the what's the coefficient out in front of the x squared there? What's 1 times 25? What times 1 is 25? You gotta get 10. You're doing the same thing, but this is a 1. All right. Now, here's what I do. Some people call this grouping. Some people call it split middle term. Some people just want to throw things at me. More people than... What I'm doing here is I'm just going to rewrite this out into 4 terms. Okay? What this is doing, it's splitting that middle term. It's making 4 parts here. So now I can factor the first 2 terms via the greatest common factor, and I can factor the second 2 terms via the greatest common factor. Like I said, this takes maybe an extra step than what normally people might do, but it forces you to get the correct answers. So here's what it looks like. I throw the parentheses over the first term like that. What's the GCF of 3x squared and a 15x? 3x. So I factor out the 3x. Inside the parentheses, what am I left with? X minus 5. Now, what I've done here is selected a problem that is the worst case scenario. Notice how the third term here is negative. What I want to do right away is I do this. I do the same change opposite because what it's going to force me to do to remember to factor out the negative. That's where most students make their mistake here. When they have a third term that's negative, they usually forget to factor out the negative. Okay? So now, what's the GCF between 2 and 10?
Negative
2. So I'm going to take out the negative 2. And what am I left with? X minus 5. Okay? What's 10 divided by negative 2?
Negative.
Okay? Now, are both those things in the parentheses the same?
Yeah.
Write it down. And what are you left with?
3x minus 2.
Splitting that middle term, factoring by grouping, however you want to call it, it does take a step longer than normal.
Oh, I remember doing this number.
Yeah, but it works every time. It's a nice, easy way of doing it. Yes, ma'am?
How'd you get that negative two?
What I'm doing here is, remember, it was minus 2x plus 10. What I did was I did before. I did add the opposite to the subtraction. So I'm adding a negative 2. What that's just, the only reason that I do that is that it's going to force me to remember that I have to factor out the negative later. Okay? It's an added little twitch to the step here because I know that you guys forget negatives all the time. This kind of alleviates that issue by putting one in here. Okay? Let me show you another one. Your book is terrible. It likes to change the variables all the time between x's and y's and h's and j's and all that stuff. And if you always write x squareds and all that, it's fine. Okay? So the first thing we're going to do, multiply first and last, and I believe you get 144?
Yeah.
Okay. So what times what is 144?
12 and
To get you 20, yeah, 12 and 12. Everybody okay with that? All right. So when I split out my middle term, I have the 9x squared plus 12x plus 12x. Yeah, I'm sorry, I meant y, but whatever. And now just do our GCFs again. So what's the greatest common factor of a 9 and a 12?
3x.
Yeah, so I factor that out. And I'm left with a 3 plus 4. And then the GCF of a 12 and a 16.
4.
I didn't have to worry about any of my signs here. Is that the same thing in the parentheses?
Yes.
We write it down, and what's left?
3x plus 4.
Can I write it as 3x plus 4 quantity squared? Now, Destiny, this is where you might have recognized first term's perfect square, last term's perfect square, and take the square root of the adds in the middle. You could have done that quicker if you recognize the pattern. But it still works. That's kind of why I don't bother with it, because it takes, sometimes you're like, well, I don't know if it is or I don't know if it's not. Okay. Not so bad, is it? Let me ask you this. What would change?
Find out.
You solve it.
You solve it. So when it gets down to the very end here, if I set that equal to 0, how do I solve for x? What do I do?
you insert
Subtract 1 add,
Well, I can't do that yet. What do I have to do to the square?
square root.
take it apart.
Take the square root. I can take it apart, but do you see how it's going to be the same answer twice?
No, I mean,
Yeah, I think I knew where you were going. So can I just say it's 3x plus 4 is 0?
Yeah.
If I just look at that, does everybody agree that I have to subtract 4?
Yeah.
And then what would you do?
Divide by 3.
So can I say my 0 is at negative 4/3?
Yeah.
Is it okay that you can state that without showing the work?
Yeah.
I hope
Fine
I'm
by me.
All right.
What's that?
Wait, wait.
What's wrong, man?
So I thought you were adding together as a parentheses.
Here?
Yeah, because there was a plus sign there.
Yeah, well, here's what I was going with. From this spot, from there, oops, are those two things in the parentheses the same?
Yeah.
That's when I just write it down, what it was, and what was left. The other terms, the 3x.
So that's when they become multiplied?
Yeah.
Got it.
Because if you think about it, what you're doing here is you're taking the GCF of these two terms. This is the GCF of the two terms.
Got it.
And I'm just writing it down, what's left over.
Okay.
So in essence, I'm using GCF like 3 times in each one of these problems without saying that I'm doing it. Okay. Does that clear that out?
Yeah.
Cool. $4x squared minus 25. It's a perfect, it's a difference of squares. Yeah, that's technically called. Is the first term a perfect square?
Yeah.
Is the last term a perfect square? Is that a subtraction symbol? Bless you. What's the square root of the first term? 2x. Good. What's the square root of the last one? There's your solution. Yay, math. Your zeros, could you write it as plus minus 5 over 2?
Sure.
Okay. Does that make sense when I said that? If this was an equals 0, did I say that my two zeros are plus minus 5 over 2? That's what I meant. Okay, that's what I meant by that. And math's nothing but problems. I just made that one up. There is one trick. I don't know if you guys I don't know if you know this trick to this. Does everybody at this point, I'm guessing you guys went and did the 15 to get -8? Yeah. -3, -5. I'll let you guys finish that out. No, check for me in a second. Hi. Quick, do that factory problem.
Okay, no thanks.
It's funny, that's what they're all saying too. Oh, this is plus, that's fine. Oh, okay.
So it doesn't have to be all.
Nope. No, you can put them in either order. If you want, did 3x squared minus 5x minus 3x plus 5, you're still going to get the same solution. You just, bless you, you just wind up with a different GCF the first go round. Yes, sir. Yes, sir. When I factor out the GCF here, it's 3x. So 3x squared divided by 3x is x. 3x divided by 3x is 1. That's what I was getting at. That's all. Just working out the GCFs. Okay. Oh, let's see. Do I even have any more? Pencil, whatever it's called.
Yeah, I know.
Hey, guys, there's no problem.
Realized that after I said it.
Yeah, give those two a shot real quick. See how you do. Did you want me to walk through either one of them?
Yeah.
Which one?
1.
All right. First rule of factoring is what? Starts with a G and ends in a... Factor out your GCF first. It's always easier.
Oh.
Work with smaller numbers. Oh, yeah. We agreed that your two terms are going to be 1 and 6?
Yeah.
Okay.
Yeah, I don't do
Are the two things in the parentheses the same? We write it down. I have to remember to bring this 2 with, though.
like 1,062, like something that.
Okay? Just remember to bring that 2 all the way down. Now, if you did start out without doing the GCF right off the bat, you might have wound up with 4x plus 2 and x plus 3, or you might have had 2x plus 6 for the other side. Remember, when you're going to factor, you have to factor down to as much as you possibly can. So this is what the smallest factored version of it would be. Correct, because if you have 4x plus 2 and the x plus 3, I can still get a GCF out of here. So what you did is you just multiplied right off the bat. By taking that GCF first, the numbers get a little bit easier, and you don't wind up getting to do that later.
So like, say you got out of 4x plus 2, you can just like
Take out the 2?
take out the 2
Sure.
and just go from there.
Yep, that's fine. You get the same result.
Yeah.
You get the exact same thing. Like I said, the only advantage of taking that 2 out first of all, it's just the numbers easier to work with. That's it. That's the only reason why I do it first. Okay? Let's see, on the other one, GCF there was what, 3?
Yeah.
One times what, 6? You add together to get 11? Oh, I'm sorry, 10. Sorry. One times what? Negative 10, negative 1.
yeah. Those are the same numbers, it's negative.
How many points are the same? You have to add one.
I'm hoping you guys got to that point. Wait. You all right? Remember, if there's not an equal sign, you just factor in all the way through. If there's an equal sign, you're just going to solve for the surface.
Actually, I'm a left. That's why I continue on my examples. I'm a devil lefties.
Let me get some problems then. This is section 5.2. I don't remember what page it is.
It's 260 probably.
260?
This is going to be easy.
Oh, I got it. You're gonna put nothing to
I wanted to do it because explain it.
That, I'm guessing. One through 2?
1 through 2 odds, right?
Yeah.
I don't care, Destiny. And it was
That'd be nice.
that made it.
No, and
Let's
it's
see, this is 260.
We made a library, it's crazy awesome. Oh,
Wait, what?
Oh, every other.
I hate when you do that.
Every other even. Now, come on, are you kidding me? This is what? 22, 26, 30, 34, 38, 42. I think it works out to be like 17 or 18 columns. Alright? I think it's only like 17 or 18 total. Is it 17? Oh, I will, yeah. There will be, no worries. It'll get there. Why? Why not? Okay? Give those a shot. We'll go over a little bit of the word problem styles we do with these things tomorrow.
We're gonna have some graphing this.
Yeah, but like I said, I'm gonna hold off on the graphics at the very end. We're gonna do all the algebra, this kind of junk first before we get to the graphing. Because
It's like a hard part.
yeah, because when I'm going to show with the graphing, we're not going to do the old, just regular old parabola. We're going to switch it around, write it in different forms. We'll do it with some conic section stuff. So it'll get a little bit more involved with it. But once you get this stuff down, the rest is pretty easy. Will you stop throwing things at me? I'm telling you. I'm nice to you.